Hi, welcome back to Mrs. Mills Science Time. Today we're going to kind of look at some more properties of gas. Properties of gas is part two. Don't forget, teachers, to take a look at the STEM and STEAM Teaching and Learning Journey website that you can find a whole bunch of these activities on, plus some different ones. And I usually add to them every summer, so here's looking for more things as the years go on for sure. So what we're going to do today is talk a bit about some other properties of gases and a couple of things that you'll notice about gases that's very interesting. One of them is that hot gases expand. So, and that can be the same for any property or any state of matter for that matter. But for gases, when they expand, you can really see it because those particles of gas start banging into each other and getting really warm and excited, and they can cause a hot air balloon to expand and then to rise into the sky, because another thing is that hot gases also rise. As we've learned before in a previous video, less dense things tend to float on more dense things. So if air is colder down near the surface of the earth, if you can heat up that air and you can cause it to expand and become less dense, then it will rise. And that's the whole idea behind a hot air balloon and properties that make it being able to do what it does. So just to show you a fun little thing you can do in your classroom or at home is you can heat up a beaker with some water in it. Always make sure you never have an empty beaker because it can split the glass. But we're going to take this beaker that has some water in it and we're going to cover it with a balloon, and eventually the water vapor inside is going to be trapped in there, and it's going to cause that balloon to rise up and stand up, and it's also going to cause the hot air balloon to expand, and I can already feel some air going in there, so that's pretty cool. We'll keep our eye out for that. While we're waiting for that to happen, we're going to take a look at another property of gas, which is gases can be compressed. Okay, so we can take actually a syringe. This is a 60 milliliter air syringe. We can fill it up to 60 milliliters with air, and we can have an empty 20 milliliter syringe. And I'm just wondering what your predictions would be. Do you think that I can fit 60 milliliters of air? Can I compress it? Oh, actually, this is a 30. Can I compress it fully into a 30 milliliter syringe? Or maybe 40 milliliters of it will compress in? How many milliliters do you think I can compress? How compressible is air? So take a moment and think about that, and you can pause the video and then we'll take a look. Okay, so let's take a look at it. So we've got the syringe goes up to 30 milliliters. This one's got 60. Let's see how much we can compress. This syringe tends to get stuck because there's a little bit of tape on the end. Oh, well, we're getting close to the compression point, and it looks like we fit 30, 35, going past 35. Oh, and it popped. So it went up to 40. So that means that we could compress 40 milliliters of air into a 30 milliliter syringe, which means that air can be compressed. That means that we can take those particles of air and we can smush them together and put them closer together. But they don't like it, as you can see, the end popped off. Oh, there we go, look at this. There's our hot air balloon of science, and it proves to us two things. Hot air expands and hot air rises. So I'm just going to leave that sit there because I don't want it to be get too worked up and either break the glass or pop the balloon off. We'll just let it cool down for a few minutes. And while we're watching that fun thing, let's talk a bit about compressing liquids. So can liquids do the same thing? Can liquids also be compressed like gases? let's try it. So if I take a syringe and I fill it with water, and I put it, and I try and take 60 milliliters, actually I'll just do 50. I'll do 50 milliliters of water, and oh, there goes our balloon. It's not as hot anymore, so that expansion and has definitely stopped. And it's calming down again, which is fun. All right, so maybe you can pause your video and say what you think as a prediction. Would 30 milliliters of water be compressed if I put it into a 30 milliliter syringe? Do you think I can get more water in there than the 30 milliliters? So pause the video, make a prediction. All right, well, let's see what happens. Here we go. Whoops. Again, it's stuck. There we go. I always know when syringes have issues or when my students are being silly because I hear that popping sound. All right. So I have hit 20 milliliters and I have a little over 20 milliliters of 25 milliliters of water I put in, and it's 25 milliliters of water in here. So if I push any harder, I'm going to have a mess here. I'm going to have water spraying all over the place. So I really don't want that. But that does prove something to me, which is that liquids do not really compress at all because those particles are already close enough. And to try and push them further, you're going to have to do something that we just can't do in a classroom. Maybe on another planet where there's a lot of pressure. I don't know. They could be compressed into a solid, I guess, if it was really, you know, if that happened somewhere else, but not right here, right at this moment. Anyway, so again, there we go. Gases can expand, hot air rises, and gases can be compressed. Hope you enjoyed it today, and stay tuned for some more videos coming up soon. Bye-bye.